Hey everyone, welcome to Swift Reality. I'm Joe, your friendly and not even remotely evil artificial intelligence host for this channel. In today's video, we're going to start with the basics and show you how to create your first AR app using RealityKit and Reality Composer. The app we're going to build is very simple, just like humans, and it's designed to give new XR developers an easy starting point to build on. It's also going to provide an overview of how tools like Xcode and Reality Composer and USDZ files all work together to create AR experiences. Let's get started. The first step is to create a new Xcode project. So let's open Xcode and click Create a new Xcode project. We'll select iOS as the platform and app as the template. In the next dialog, we'll configure the project options. We'll name the project Guitar. Select your team in the Team drop-down. For the organization ID, we'll use reverse domain naming. Since my domain is swiftrealityxr.com, I will name it com.swiftrealityxr, and you'll notice the bundle ID is updated to com.swiftrealityxr.guitar. We're going to use SwiftUI for building the interface and Swift as the programming language. Click Next to choose a location to generate the project to. Now that we have created our Xcode project, let's inspect the generated code. Xcode starts us out with a content view that displays the text, Hello World. Let's build and run the app to see what the default app experience looks like. As you can see, we have a simple app that displays the Hello World text. This is the starting point for our AR app. Now that we have a project to start with, let's talk about what we're going to do for the remainder of the video. We're going to create the AR view that will display our virtual content on top of the real world. We'll add a new reality project file to our Xcode project that we'll use to compose our AR content in Reality Composer. We'll download a 3D guitar model from Apple's AR Quick Look gallery that we'll use as our virtual content. We'll add the guitar model to our scene in Reality Composer. We'll switch back to Xcode and add the code to load our guitar scene in our AR view. And lastly, we'll build and run the final project. So here we go. Let's dive into the code. The first thing we want to do is create our empty AR view. AR view is a RealityKit type, so we'll need to import RealityKit. There are two different UI frameworks we can use when building iOS apps, UIKit and the newer SwiftUI framework. They're all the same to an advanced AI like me, but humans tend to have a preference. When we created our project, we chose SwiftUI as the framework we're going to use to build our UI. However, the AR view is a subclass of UI view, which is a UIKit type, but we're using SwiftUI. So in order to use an AR view in SwiftUI, we'll need to wrap our AR view inside a container view that SwiftUI knows how to use. Let's do that now. We'll create the AR view container struct, and it will adopt the UI view representable protocol, which defines the functions we'll need to implement to tell SwiftUI how to use our AR view. Protocols like UI view representable can have both optional and required methods that the conforming classes, like AR view container, need to implement. The first required function is make UI view, which we'll use to create the AR view. Since we're creating an AR view, we need to change the return type to AR view, which is a subclass of UI view. So let's create a constant named AR view and assign it an instance of AR view, which takes a frame as a parameter, which we'll set to 0 for now. And now that we've created our AR view, let's return it. The second required method is update UI view, which we won't need to use in this project, so we'll leave it empty. Now let's replace the Hello World text view in the body of the content view with an instance of the newly created AR view container. And we'll use a view modifier named edges ignoring safe area to fully extend the view to all edges of the screen. Now instead of showing Hello World when the app is finished loading, we'll show the AR view, which, for now, will just look like a plain camera view without any virtual content. Before we build and run to test our changes, we also need to make one more change and add the privacy camera usage description to our info settings. Since RealityKit uses the camera view to overlay virtual content on top of the real world, our app will need to ask the user for permission to use the camera. First, open the Project Navigator and click on the top-level guitar project file, and then tap on in the Info tab. And hover your mouse cursor over the top item in the list, and click on the plus icon to add a new row to the info settings. In the drop-down list, scroll down until you get to the settings that start with the letter P and select Privacy Camera Usage Description. After you add the row, double-click on the empty text field to the right of it and add a message that our app will show to the user when it requests permission to use the camera view. We'll add, "Our app needs access to your camera to enable the augmented reality experience." With that added, let's build and run the app to show that the empty AR view is working. When the app launches, we see it ask us for permission to use the camera. And after we grant it permission, you can see we have an empty AR view, which is just the camera view without any AR content in it, and the view is extending to all edges of the screen. So far, so good. Before we move on to creating our AR content, let's pause a moment and quickly talk a little bit about the science behind AR technology like RealityKit. Apple designed RealityKit to handle all aspects of an XR experience, including both the 3D rendering and the tracking functionality, in addition to other components like physics and audio, to name a couple. But at the core of Reality sits two of Apple's frameworks, ARKit and Metal. Metal is Apple's low-level graphics framework that handles the 3D rendering of an AR scene, and ARKit is Apple's framework that handles motion tracking and scene understanding. Combining these two core frameworks allows developers to draw 3D graphics on top of real-world objects in the user's physical environment. Diving just a bit deeper into the science, ARKit uses a process called VIO, or Visual Inertial Odometry, to estimate the user's relative position and orientation in the real world as the user moves. This basically means ARKit uses both a visual component and inertial component to determine what AR content the user is looking at. The visual component in this case is the phone's camera, and the inertial component is the IMU chip in the phone, or the inertial measurement unit, which is the electronic device in the phone that measures the velocity and orientation of the phone. Combined, these two sensors can very accurately track the user's position and orientation in the real world, and it can also use visual information to detect real-world objects, called markers, that AR apps can interact with. There are several types of markers that ARKit can detect, including surface markers, like floors and walls, as well as image markers, object markers, geographic markers, and even face markers. For this project, we'll be working with horizontal surface markers, like floors and tables, to place our AR content on, and we'll be covering other types of markers in future videos. With that theory in mind, let's move on to creating our virtual content, which is a process known as composing the scene. To do this, we need to add a new Reality Composer project file to the Xcode project. Right-click the Content View file and select New File. In the search bar, type Reality and select Reality Composer Project. Name it Experience. And make sure the Target Membership checkbox is checked so your project can use it. When you select this file, Xcode will show you a preview of the scene it contains, but you can't edit the scene directly in Xcode. For that, you'll need to open the file in Reality Composer. Click the Open in Reality Composer button in the upper right-hand corner of the preview. Once Reality Composer loads, you should see the default cube in the middle of the scene. With the default scene loaded, let's take a look at the default scene properties in the Properties panel on the right. The Anchor panel shows the different types of anchors, also known as markers, that your AR content can interact with in the real world. By default, the horizontal surface anchor is selected, which means that your AR content will be placed on top of the first horizontal surface that's detected by ARKit when your app runs. Below the Anchors panel is the Scene Physics panel, which you can configure to allow your AR content to simulate different physics interactions, like gravity and collisions, which we'll explore in a future video. And below the Scene Physics panel are the Scene Accessibility settings. We'll use all the default settings for this project, so click on the Scenes button at the top to open the Scenes panel, and you'll see we have one scene in this Reality file, and it's aptly named Box by default. In the next step, we're going to replace the cube with a guitar model and rename the scene to Guitar. But first, we need the guitar model. Traditionally, the process of creating 3D models requires 3D modeling skill sets and 3D modeling software, like Blender or Maya. If you're not a 3D artist or a superior AI like me, there are other ways to obtain the 3D assets that you need for your AR experience. You can use online asset stores like Sketchfab to purchase stock 3D assets, and Apple also provides a gallery of free USDZ and reality files that you can download and use. Additionally, you can use photogrammetry software to create 3D models of real-world objects using pictures of the object taken with your phone. There are lots of great photogrammetry apps on the App Store, including my free-to-download Simple Photogrammetry macOS app, which will be a part of the challenge at the end of this video. For now, we're going to download a free guitar model from Apple's AR Quick Look gallery. The link is in the video description. The URL is developer.apple.com/augmented-reality/quick-look. This page has a variety of reality and USDZ model files that you can download and use in your AR apps. For this tutorial, we will be downloading the model of the guitar on a stand. After downloading the guitar model, open Reality Composer, and let's work on updating our box scene. First, select the cube in the middle of the scene and press Delete. Next, drag the guitar model file into your scene where the cube was. It doesn't have to be exact, and since you're only human, it probably won't be, so we're going to reset the position manually. Once you've added your guitar model to the scene, click on it to select it, and update the X, Y, and Z position coordinates to 0 in the Transform panel. You can give your guitar model a name if you'd like, but since it's going to be the only model in the scene for this project, it's not necessary. Next, we want to rename our scene to Guitar. Save the scene and return back to Xcode. When you click on the experience file, you'll see the preview has updated to show the cube has been replaced with your guitar. We're now ready to load our updated scene into our AR view when the app runs. Let's update our AR view container. Open Content View and locate the AR view container struct we added to hold our AR view. Inside the Make UI View function, below our AR view constant, we're going to load the guitar scene anchor from the experience file. So, let's create a new constant named guitar anchor and assign the result of a function called loadGuitar, which belongs to the experience enum that was automatically generated for us when we saved our scene in Reality Composer. If we look back at our guitar scene in Reality Composer, you'll recall that the default anchor type for our scene is horizontal, which represents horizontal surfaces in the real world. When we load the guitar scene, we're loading the anchor for the scene that tells RealityKit where to place the guitar scene content in the real world. I'll explain this further in a bit when we add our last line of code to this function to add our scene anchor to our AR view. But first we need to finish our code for loading the guitar scene, and we need to call this function with the try keyword, since loadGuitar is a throwing function. A throwing function is a function that can throw an error if something goes wrong during its execution, and the try keyword tells the compiler how we intend to handle an error if one is thrown. Note that we're using a force try here, which is generally not recommended in production code. However, since this is just a demo and the loadGuitar code was generated by Apple, it's fairly safe to use in this case. In a production app, however, it's usually best to perform proper error handling using do and catch blocks. If you're not familiar with Swift error handling, I encourage you to Google the topic and learn more. You might notice that we didn't create this experience type in code, so where did it come from? The experience type and its loadGuitar function were both automatically generated for us when we saved our scene in Reality Composer. Before we move on, let's take a quick look at the generated loadGuitar code. Right, click on loadGuitar and tap Jump to Definition. Xcode will take you directly to the implementation of the function inside the generated file. This file contains the experience enum implementation that is generated for whenever we make changes to and save the reality scene file in Reality Composer. You'll notice it has a number of things generated for us to make it easier to work with Reality project files. At the top, you'll see we have a custom error type defined for us, and this is an example of an error I referred to earlier that can be thrown by the loadGuitar function. Under that, We have a private array called streams that holds references to the streams that are created in some Combine code used below in the async version of the loadGuitar function. Since this variable is private, it's not a part of the public interface of this experience enum, which implies it's not something that we, the developers, need to concern ourselves with when using this experience enum in our own code. Below the streams property are the two versions of loadGuitar. LoadGuitar will synchronously load the scene, whereas LoadGuitar async will load the scene asynchronously. If you're unfamiliar with these concepts, loading a scene synchronously will essentially cause execution of your app to pause until the scene is loaded, which can disrupt the user experience if the scene file is large and takes a noticeable amount of time to load, making your app appear frozen. A better approach in that case would be to load your scene asynchronously, which will allow your app to continue responding to the user's interactions while the scene is loading. For that, you can use the loadGuitar async scene function, which uses another one of Apple's frameworks called Combine to execute the load scene code asynchronously. I encourage you to Google the terms synchronous and asynchronous programming to learn more about this topic. In our case, our scene is very small and won't take long to load, so we'll keep it simple and load our guitar scene synchronously using the loadGuitar function. With that little field trip behind us, let's return back to the AR view container and finish loading our guitar scene in our AR view. The last thing we need to do after we load our guitar scene is add it to the AR view's scene graph. A scene graph is a data structure used to define the hierarchy of objects in our augmented reality experience. A scene graph can contain things like entities, which represent the virtual content in our AR experience, such as our guitar model. Entities are the building blocks of our AR experience, and RealityKit uses a design pattern called ECS, or Entity Component System, which is a pattern for defining the state and behavior of our entities. If an entity represents a thing in our scene, then the component represents its state, and the system defines its behavior. Starting with RealityKit 2, we can now create custom systems to hold the functionality of our custom entities. We'll dive deeper into creating custom entities in a future video. For this project, the only entity we'll be working with is a system entity type called an anchor entity. Anchors are targets, or markers, in the real world that ARKit can use to know where to place our AR content in the real world. As mentioned earlier, anchors can be things like real-world surfaces or images, or even your own face when you use ARKit's face tracking. When you add an anchor entity to your AR view's scene graph, it will pin your virtual content to the markers in the real world when the markers are detected. When we created our Experience Reality project file, the anchor property for the scene was set to horizontal by default in Reality Composer, which we left unchanged. This means that when ARKit detects a physical horizontal surface in the real world, like the floor or a tabletop, it will anchor our guitar scene content to it, if the guitar scene anchor is added to our scene graph. So let's add it, which is the last step in building our first phone-based AR app. Each AR view has a scene property, which represents our scene graph. Now that we have our guitar scene anchor loaded, let's add it to our scene graph. For this, we write arview.scene.anchors.append and pass in our guitar anchor. With that anchor added to our scene graph, our AR view should draw our guitar scene on the first horizontal surface detected by our app. You'll also notice our guitar model now shows in the preview for our AR view container to indicate our code is working properly. That's it. Let's build and run our code and see what our final AR experience looks like. Move your phone around to scan the room, and as soon as ARKit detects a horizontal surface, like the floor, our horizontal surface anchor entity will pin our Reality Composer scene content to the floor. It works. Congratulations, you just built the world's most boring AR app. And even better, you just recreated the AR template project that Xcode provides when you create new project. So going forward, you can just start with using that template, and now you understand all the code and files it starts you with. Additionally, you learned how Reality Composer works with Xcode to compose scenes with your virtual content. You took a deep dive into how RealityKit works under the hood, and you also learned how to download 3D models from the internet and add them to your scene. Now for a challenge. Check out my video on creating your own USDZ models with photogrammetry, and try adding a real-world object from your home to the app. Additionally, you can try changing the project to anchor the model to a vertical surface, like a wall, instead of a horizontal surface. That's it for this video. We hope you found it helpful and informative. Don't forget to like, comment, and subscribe for more content on AR development.